Okay, greetings one and all, and welcome to this math video. In this math video, we'll be considering the topic circle theorem. Yes, circle theorem. Let's begin. Okay, the question says circle ABC has a center at O. DE is tangent to the circle at C. Angle BAC equals to 37 degrees and angle ADC equals to 65 degrees. Find angle ABC. And so here we have to consider the one that's in the middle. That's the one that's going to be under special significance. And so the one that's in the middle is going to be B. And so let's put a point at B. Next, we're going to go to A, and we're going to put a point at A. All right, next we're going to go to C, and we're going to put a point at C. Okay, good. Then we're going to connect B to A. So let's connect B to A. And then we're going to connect A to C, connecting A to C using this line segment. And then we're going to connect C to B, C to B. Now the question is, what is angle ABC? So which one are they talking about? They're referring to angle B, so the one in the middle. So they're referring to this angle right there. What is going to be the size or the measure of this angle? As you can see, it looks like that we are in a triangle. But what is going to be the interior angle of this triangle? B, right? So in order to answer this question, we will consider a very useful and important circle theorem entitled angles in a semicircle. And the theorem says that the angle in a semicircle is 90 degrees. If you notice here, we have this green line. This green line is what is the diameter. This green line is the one that separates the circle into two even portions, making sure that this side is a semicircle as well as this side is a semicircle. So if you look carefully, this right here is what we call a semicircle. It's half of a circle, right? Exactly half of a circle. All right, and then this one right here is what we call a semicircle as well because it's also half of a circle. So we have two semicircles. Okay, let's move on to the next part. If we look carefully, we see that this angle right here is 90 degrees because the angle in a semicircle is 90 degrees. So this right here is 90 degrees. So that means that here, this angle right here is going to be 90 degrees. Now, how do we know that? Because we are also dealing with an angle in a semicircle. Because if we look at this one, here is the origin. And if we go right here and consider the line angle and consider line AC, we'll notice that this line AC passes through the origin, all right? Passes through the center. And so we have angle AC, sorry, we have a line AC, and like I said, it passes through the origin, so that means that line AC is what we call the diameter, because the diameter passes through the origin and touches end to end. That means that this line divides this circle into two even portions, so that means that this part right here is a semicircle, right? This part right there is a semicircle. This part right there is a semicircle. Okay, so if that's a semicircle right there, then that means that this angle right here is 90 degrees. Based on the theorem, which says that the angle in a semicircle is 90 degrees. Okay, let's move on to the next question. We need to figure out what is angle BCE. Angle BCE. That's what we need to figure out. What is angle BCE? All right, so if we look at angle BCE, that means that we're looking at this particular, let me underline it. That means that we're looking at, let me use a pen. That means that we're looking at this particular angle, angle BCE. All right, angle BCE, the one that is in the middle, angle BCE. Now, where's angle BCE? Well, angle BCE is going to be, well, let's just consider. We have to look at angle C right here. So angle C is going to be the one that's right here. That's angle C. And then we got to look at B again. First, let me erase everything before so we can have a clear image. So angle C is the one that's right here. That's the one that's in the middle. That's the first one we consider. Let's look at B. B is gonna be right here. Let's look at E. E is gonna be the one that's right here. All right, and so what that means is that we have angle C, we have angle BCE, angle BCE. And so if we go here, let's draw a line. The line goes here, continuing and continuing, continuing. All right, and then it goes here, continuing, continuing, continuing. And so that means that angle C is going to be the one that's in the middle, right? Angle C is the one that's in the middle. So we're looking at this particular angle right here. That's the angle that we're looking at, this particular angle. Now, for this particular question, we're going to use a theorem, a very important and useful theorem. The theorem is called the alternate segment theorem. And the alternate segment theorem, because remember we're trying to find this angle right here. Let me redraw it. And we're trying to find that angle. Now the alternate segment theorem says the following. It says the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so here, this black line right here is what we call the tangent line because it touches the circle at one point, right? And we have this green line, which we call the chord. It's called a chord. And so the angle formed between the tangent line, the black one, and the chord, we call it theta, all right? And it says the angle that lies between the tangent and the chord is equal to the angle subtended by the same chord. So it's going to be equal to this particular angle right here. So that means that this one and this one are equal. And so when we say that that the angle subtended by the same chord, what we basically mean is that if you look at this particular if you look at this particular leg of the angle, right, along with this particular leg of the angle, right, the base of these legs is going to be the chord, right? The base of the legs of this angle is going to be the chord. And so that's what we mean by this angle theta is subtended, right? That's what we mean that when we say the angle theta is subtended by the chord, it means that the base of its legs, or we say the bottom, if we say that, we could say what we basically mean when we say the angle is subtended by the same chord is that if we were to form a triangle, right? With the base, if we were to form a triangle with the legs of this angle, right? The base of that triangle would be the base of that triangle would be the chord. All right. And so let me repeat that again. When we say that the angle is subtended by the chord, what we basically mean that if we were to form a triangle, right, with the legs of the angle, the base of that triangle is going to be the chord. All right. And so that's what we mean. The chord is the base of this triangle that theta is inside of. And so that means that the angle is subtended by the chord. Okay. And so if you look carefully in layman's terms, this chord forms the base of this, of this triangle. And this chord forms like, it is like if we were to remove this chord, it's like this angle is hanging by itself, right? But by putting that chord there, the chord is like the base of it, like it closed the gap. So this angle and this angle are equal, right? And so the same thing applies here, right? We have the tangent line DE, that's the tangent line, right? And so we have this tangent, or this part is part of the tangent, right? CE is part of the tangent. We have the tangent line, the angle formed between the tangent line and the chord BC, right? That's the angle right here. So this is the angle right here formed between the chord and the tangent line. And we said that that particular angle is going to be equal to that particular, we said that that particular this particular angle is going to be equal to the angle subtended by the same chord. And so if we look here, if we were to form a triangle using the legs of this angle, all right, the base of the triangle is going to be the chord. And so that means that 37, the angle who measures 37 is subtended by the chord CB, which means that if this part is 37, that means that this part is 37 because they're supposed to be equal to one another. And so that means that this, right, this angle is 37, right? This angle is 37. This angle is 37. And so BCE, angle BCE, right? Angle BCE right here is equal to 37 degrees. Why? Because of the alternate segment theorem, the angle that lies between the tangent and the chord is equal to the angle subtended by the same chord in the alternate segment. Okay, let's move on to the next question. Here we have angle DAC, angle DAC. And so remember, D is the one that's in the middle. So that's the first one we can be considering. So let's put a point here, right? And then, sorry, A is the one. I hope I didn't say D, but A is the one that is in the middle. So since A is the one that's in the middle, we're going to put a point at A. And then we're going to put a point at D because D is also there. All right, so put a point at D. And we're going to put a point at C. All right, put a point at C. Now, if we look carefully, this forms another shape. If we move from C to A, that's a line segment. If we move from A to D, that's another line segment, A to D. And if we move from D to C, that is another line segment. And so what they want us to find, they want us to find the angle A, right? So they want us to figure out, like, what is this angle? Like, how many degrees is this angle? What's the size of this angle? All right. Okay, great. Now, if we consider this shape, we'll notice that this shape is what? It is a triangle in shape, right? And if we look here, DC is part of the tangent line. And so there's a circular theorem that says that, let's see if we have it here. There's a circular theorem that says that the angle between the tangent and the radius is 90 degrees. So if we look at CO, right, this is the center of the circle, and this is the end of, sorry, this is the angle, sorry, O is the origin of the circle. O is the origin, and this part right here is at the circumference. So if we look at line segment OC, right, or CO, if we look at that line segment, this is definitely the radius because this point is at the center and this point is at the edge of, sorry, this point is, yeah, this point is on the outside of the circle, or I should say on the circumference of the circle. And so line segment OC is definitely the radius. And so the angle formed between the radius, which is this one, angle CO. So that's the radius, right? That's the radius R. Let's call that the radius. So the angle formed between the radius and the tangent line. So the tangent line is this one. So the angle formed between the radius, right? The radius, sorry, let me not do that too much. The angle formed between the radius, let me erase that. The angle formed between the radius, let's make sure that's clearly denoted. The angle formed between the radius, stop at O, the radius and the tangent line, which is this. The angle formed between the radius and the tangent line equals to what? 90 degrees. And so this right here is going to be equal to 90 degrees. Now, what does that mean? What that means is that we now have two angles of the triangle. So this right here is 90 degrees. This right here is 65. We just need one more angle to finish up the triangle. And we know that angles in a triangle add up to 180 degrees. And so that means that we're going to subtract. Well, first we're going to add 65 and 90, right? Add 65 and 90 and then subtract that from 180. So 65 plus 90. What is 65 plus 90? 65 plus 90 is 155. All right, 155. And so we're going to take 155 and subtract it from 180. And that gives us 25. And so the answer here is definitely going to be 25. Okay, let's move on to the next question. Here in 2016, it says AB is a diameter of the circle. ABC, sorry, AB is a diameter of the circle ABC with center O. AD is a tangent to the circle at A. Angle ADC equals to 56 degrees. And so here we have a diagram. And the first thing that they ask us to do is calculate angle BCA, angle BCA. So here, what we have to do is we have to consider the angle in the center. All right. We're talking about angle C. And let's look at angle B and angle A. So it's going to be C. So we have, and then we also have B, right? So angle BC, sorry, angle BCA. All right, so let's move. So it's going to be angle line segment BC, line segment AC, line segment AB. Okay, good. Okay, so what do we have? It says, what we're trying to find? We're trying to find out what is angle C. And so angle C is going to be equal to what? Angle C is going to be equal to this one. This angle, the interior angle right there. All right. And so in order to answer this question, we have to consider a useful theorem. The theorem is the angles in a semicircle theorem. And we know that it's a semicircle because if we look carefully, right? If we look carefully, this is the origin, right? This right here is the diameter, which splits the circle into two. And then if we go here, all the way around, that's a semicircle. All right. And so the angle right here, which is C, the angle right here is going to be 90 degrees. So the answer is 90 degrees. What's the reason? Angles in a semicircle. Okay, let's move on to the next question. All right, so the next question says the following. Angle ABD, angle ABD. All right, angle ABD. So here's A, here's B, angle ABD, angle ABD. Here's A, here's B, here's D. It's going to be from angle A to D. Angle A to B. And angle B to D. And so what we have to do is we have to figure out, okay, what's the size of angle B, the one that's in the middle? So we're going to figure out what is the size of angle B. So we're going to figure out what is the size of this. We already know that this one right here is 90 degrees from our first question. So this right here is 90 degrees. But the question is, what is this angle right here? All right, that's a very important question. So what is that angle? So we have angle, this angle B right here. We have this angle is 90. All right. But this is not, but this is irrelevant. We don't need this about our question. What we need to remember is this one. If we remember carefully, there's a theorem that says that the angle formed between the radius, this is a radius, right? The angle formed between the radius and the tangent. The angle formed by the radius and the tangent is equal to 90 degrees. So this right here is 90 degrees, right? So we have 90 degrees, all right? Let me erase the one in the bottom. So we have 90 degrees, 56, and we don't know what this one is. In order to figure out what this one is, what we have to do is we have to add 90 and 56 together, add them together, and then subtract it from 180 to get our answer. And so we have 180 Okay, 180 minus, okay, let me go back to this original one. So 180 going to be equal to 180 minus 90 plus 56. And so what we have is 100 minus 90 plus 56. So it's going to be equal to 34. All right, so the angle here is going to be 34 degrees. What's the reason? All right, because angles in a triangle add up to 180 degrees. That's going to be equal to 34. All right, let's move on to the next question. It's angle CAD. Angle CAD. So we have A in the middle. So it's angle CAD, angle CAD. So we're gonna take C, keep that point. Oh, but let's start off with A. So A in the middle. And then we have D, where's D? D is right there. All right, so we have angle C to A, and then angle A to D, and then we have D to C. All right. All right, so here we have angle CAD, 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 which means that the one that we are taking in consideration is this one, right? CAD. Really consider it in this one. Okay, so let's look at it. So, all right, so what we have to do is the following. So we have CAD, CAD. Okay, this is gonna be equal to, all right, so angle CAD. Here I answered it using the alternate segment theorem. So let me see what I have. Okay, yeah, that makes sense. Because, okay, so we know that this angle right here is angle CAD. We already know what this angle right here is. This is angle ABD, and we saw that that was 34 degrees. And so this right here is 34. All right. And so if this is 34, that means that this must also be 34 because of the alternate segment theorem. Now, let's prove it, because if we notice carefully, this line right here, along with this line, um, these two legs of the angle, um, if we form a triangle, the base would be AC, that chord, AC. And that's the same chord that that's the same chord um that's the same chord that is between the tangent line. This is the tangent line, and this is the chord, right? So the chord is AC, and the tangent line is AD, part of the tangent line. So the angle formed between, this is the angle formed right there, between the tangent, which is AD, right, and the chord is equal to the angle subtended by that same chord. So this is 34, this is 34, and this is also 34. Okay, so what that means is, so that's the alternate segment theorem. And like I said, this is 34 right there, and this is also 34. All right, so let's move on to the next question. In the diagram, O is the center of the circle, LMN. So this right here is the center of the circle. So if we look carefully, O, which always stands for the origin, right? O is the center of the circle, LMN, and angle LNM equals to 38 degrees. This right there is 38 degrees, and the line PN is tangent to the circle at N. All right, that's this line PN is a tangent line. All right, it's tangent to the circle, and in fact, this entire line is a tangent line. The line PN is tangent to the circle at N. Calculate the value of angle LMN, angle LMN. So first, let's identify what is angle LMN. First we have to figure what is, let's figure what is the one in the middle. So that's M. Let's see where M is. M is right here. Okay, so that's angle M. And then let's see where L is. L is right here. Okay, that's where L is. Where is N? N is right here. And it's gonna be right there. Okay, so that's N is. And so let's form a line M to N. All right, it's gonna be right there. And then M to L is gonna be right there. And then L to N, L to N is going to be right there. All right. And so what we're looking at is we're really trying to pinpoint or emphasize angle M, because that's the one in the middle. So what the question really is asking us for, what is the value of this angle, right? This one right there, what is the value of this angle, right? And so that's the question right there, what is the value of that angle? If we look carefully, this is the angle M that we're looking for, this one. So we're looking at angle, what they say, how they call it? They say LMN. All right, and that's how you have to find it. You have to look for the one in the middle and see what shape it's connected to. This definitely looks like a triangle. For this one, we're gonna use the same theorem that we used earlier, which is angles in a semicircle. And the theorem says that the angle in a semicircle is equal to 90 degrees. So let's pinpoint the semicircle. And so let me use, say, baby blue. So if we look here, this right here is the origin. And so that means that this line right here is the diameter, which splits the circle into two. And that means that this part, right, is half of the circle. This is a semicircle right here, the part that is outlined in blue. And so we said that the angles inside the semicircle is equal to 90 degrees. And so that means that this angle right there, we said that the angle inside the semicircle is 90 degrees. So that means that this angle right here is 90 degrees. So angle M is 90 degrees. And the reason why it's 90 degrees because because of the theorem, which we entitled angles in a semicircle, right? It's equal to 90 degrees because the angle in a semicircle equals to 90 degrees. So this right here is 90 degrees. Okay, so let's move on to the next question. It says calculate the value of MLN. MLN. Now what is going to be MLN? Well, let's identify it. The first thing we're gonna look for is definitely L. So this one right there is L. And so that is the one that we're looking for, angle L. And then we're gonna look at M. Where's M? M is going to be right here. And we're gonna look at N. N is going to be right there. And so what do we have? Let's finish it. It's gonna be, let's complete the shape. So we're gonna go from M to N. So from M to N. And then we're gonna go from M to L. Then we're gonna go from L to N. L to N. And so we're really looking for angle L. And so we have to emphasize this particular angle. All right, and what would this particular angle be equal to? Well, the first thing, if we look at this is the one that we're trying to figure out, right? This angle, angle L. Let's remember that angle M is 90 degrees. All right, angle M is 90 degrees. And so since angle M is 90 degrees, that means that we have two angles in a triangle. So we know that angles in the triangle add up to 180 degrees. So we have angle M, which is 90, and this is 38. So we have to add them two, then subtract it from 180 degrees. So it's going to be 180 degrees minus 90 plus 38. If we add 90 and 38, we get, and this is very important, let's add 90 plus 38. 90 plus 38. 90 plus 38 is 130, and is 128. So basically what we have is 90 plus 38. So 90 plus 38, that's going to give us 128. And then we take 128 and subtract that from 180. So 180 minus 128, okay? And so when we do that, we know that we borrow from the 8, that's going to be 7. This becomes 10 minus 8, which is going to be 2. And then 7 minus 2 is going to be 5. So that's how we get 52 right now. Okay, we first add 90 and 38, which gives us 128. And then we subtract 128 from 180 to give us 52. Okay, let's move on to the next question. The next question, they ask us for angle MNP, angle MNP. All right, so let's consider it. We want angle MNP. So let's consider angle N. So this right here is angle N, right? And then we have M. So let's go to M. M is right there. Let's go to P. P is right there. There's P, 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 P. Okay, so P is right there. So what we have to do is we have to join them. Let's see what shape we find. So M to N, M to N. Okay, and then we go from N to P, N to P, N to P. Okay, that doesn't look so pretty, so let me draw it properly. N to P, N to P. Good. And so the angle that we're trying to focus on is the one that's in the middle, right? So we're trying to focus on angle N. And so that means that we're going to be looking at this angle right there. This one right there. And so the question is, what is this angle, right? We already know that this one is 90. All right. We know that this one is 90. And we also know that this one, we saw this one earlier, we said that that one is 52. Okay, and so for this one, we're going to use the alternate segment theorem again. And the alternate segment theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so if we look carefully here, here PN, that's the tangent line, right? And then MN, that's the chord, right? So the angle formed between the tangent line and the chord is this one, right? And the angle that is subtended by the same chord on opposite or on the alternate segment is definitely this one. And so the answer is definitely 52. And the reason is because if you look carefully, right? If you look carefully, what we have is we have the legs of this angle 52, and the legs of this angle form the base, right? And the chord, right? The chord form the base of the legs of the angle. And so that means that this angle, right, 52, this angle that measures 52 is subtended by this chord because this chord is the base of the triangle that is formed using the legs of this angle, right? And so it's basically, if you look at it, this MN, this chord is basically the thing that basically the angle depends on. Like it is the base of the triangle as formed from the legs of this angle, and it's as if this line MN is what holds it up, right? Because if you move the chord MN, it's just like the angle is just hanging there, right? And so this forms a good structure or base for it. And so angle MNP is definitely 52 degrees because of the alternate segment theorem. Okay, let's move on to the next question. This is question number 20. This is 2014. It says, in the diagram, O is the center of the circle. So here's O. AB is tangent to the circle at A, and ADB is equal to 52 degrees. And so it says, calculate the value of CAD. Calculate the value of CAD. Well, the first thing we're going to do is we want to consider what A is. All right, so let's look at A. And so A is right here in the middle. And so we're going to look at this right here, put a point there. And then we got to look at C. Well, C is right here. All right, C is right here. And then we're going to look at D, right? D is right here. D is right here. And so let's form the shape, right? Let's connect the vertices. Let's connect the vertices. And so D goes with C. And then C goes with A. All right. C goes with A. C goes with the line segment A. And then A goes with D. All right. A goes with D. And so if you can see clearly, we're forming a shape that has three sides, and it's definitely a triangle. But the angle, the interior angle of this triangle that we're interested in is this one, angle A, right? And so we're interested in this one, this particular angle right there. That is the one that's of interest for us, this particular angle right there. And so what we're looking at is the angle A, right? The angle that's in the middle, angle CAD. We're looking at this angle right there, right? And so the question is, how are we going to figure out what this angle is, right? What theorem we could use? Well, what we can figure out is, okay, let's see what theorem we use there. Okay, so the theorem that I have here is the angle between the tangent and the radius is 90 degrees. Okay, well, what is the radius? What is the radius and what is the tangent? Why would I use that one? Okay, let's see. So if we look carefully, let me use another color. First of all, if we look from here, oh, I see it now. I see it. If we look from, it's kind of the wrong side. If we look from here, this is the origin, right? If we look at here to here, let's go down. If we look at from here to here, this is the radius, right? That's the radius because it is half of the diameter, right? It's a line that goes from the point to the circumference, so it's definitely the radius. So we're gonna call this R, right? That's the radius, right? And then we also have, let me use the green. We also have the tangent line because this line right there is the tangent line, okay? So that means that the angle that is formed between the purple line, which is the radius, and the green line, which is the tangent, is supposed to be equal to what? This is supposed to be equal to 90 degrees, okay? And so that's very important. So if we look here, the angle formed between the radius, R, and the tangent, right? The tangent line equals to what? 90 degrees. And so this right here, this full thing right here is 90 degrees, right? This full thing is 90 degrees. So one thing we do know is that whatever A is, whatever this one is definitely going to be less than 90 because this whole thing is 90 degrees, which includes this angle, right? This whole thing is 90 degrees. Okay, so that means that this smaller angle is going to be less than 90. We could also use the alternate segment theorem. And the alternate segment theorem would tell us that if this angle, right? Let me use a different color. If this angle right here is 52, right? If this angle is 52, that means that this angle right here is also going to be 52 degrees. So that's what we have. That's a good one. How do we know? Because look, remember the theorem tells us that the angle formed between the what? Between the tangent, which is the one in green, right? And the chord, which is the one in red, right? Is going to be equal to the angle subtended by the chord. And so the angle subtended by the chord is going to be 52 degrees. So this one, 52, and this one is 52, all right? And so what does that mean? That means that we know that this is 52, right? We're trying to figure out what this is, right? But we know that both of them combined should add up to what? 90 degrees. That's very important. Let me repeat myself. We know that this is 52, but we don't know what this one is. But we know that both of them combined should give us what? 90 degrees. How do we know that? Because those are the angle, that's the angle between the radius, right, and the tangent. And the angle between the radius and the tangent is 90 degrees. All right, that's what this theorem says. The angle formed between the radius and the tangent is 90 degrees. So that means that this one, right, that means that these two combined should give us 90. And so if we were to try to figure what this one is, we have to subtract 90. We have to subtract 52 from 90, and 90 minus 52 is definitely 38. And so that means that this angle, right, this angle right there, let me show you it. That means that this angle here is going to be 38 degrees. And the reason why that angle is 38 degrees is because if you add 38 and 52, you're going to get 90 degrees. Okay, so that's a lot of things. So let's move on to the next question. It says CAB. So we got to look at this angle right now. That's angle A. Let's put a point here. And then we got to look at C. And so C is right here. Right, and then we're going to look at angle B. Angle B, angle B. Where's angle B? Okay, B right there. Okay, so let's draw it. So we have, let's go to the line segment from C to A. The line segment from C to A. And then we're going to go from A. We're going to go from A to B. From A to B. We're going to go from C to B. Let's go from C to B. Again, we're going to go from C to B. So from C all the way down to B. From C to B. And the one that they have so it's C. Sorry, it's A rather. CB, right? So CAB, right? So the one that's just in the middle is going to be A. So what we're really trying to figure out is what this angle is, all right? And we already figured out what this angle was, right? Remember we used the alternate segment theorem. And the alternate segment theorem tells us that the angle formed between the tangent line, right? This is the tangent, right? The angle formed between the tangent line and the radius. Sorry, the angle formed between the tangent line and the chord, right? It's going to be equal to the angle form. It's going to be equal to the angle form. It's going to be equal to the angle subtended by the same chord. And so the angle that's subtended by this chord is going to be, let me use the highlighter. Let's use this color. The angle that's going to be subtended by this chord is this angle. Because if you notice that the legs of this angle, right? The legs of this angle. So if you look at it, the base, so if you look at it, the chord CA forms the base of the triangle that is formed by the legs of this angle. All right, so basically, CA acts as the base for the legs of this triangle, right? It rests on this chord. So that's what we mean by this angle is subtended by the chord, right? Its legs, right? Its legs rest on the base. Sorry, its legs rest on this chord, and the chord acts as the base for the legs of this angle. And so that's what we mean by the angle is subtended by the chord. And so that means that if this is 52, that means that this must also, this angle right there, right, must also be 52. 52. Let me erase that, draw a proper 52. 52, 52, 52. So 52. Let's use 52. 52 degrees. And so the angle there is going to be equal to 52. And what does that mean? We know that because of the alternate segment theorem. Okay, now the next question is, what do I have? Okay, the next question, let me erase everything. Erase all ink. Can I? Yes. The next question is this one. Let's look at CBA. So the one that's in the middle is B, sorry. And so what we have to do is we have to put the point at B. And the next angle, the next one that we're gonna look for is C. So we're gonna put the point at C. Next one we'll be looking for is A. So we're gonna put a point at A. Then we're gonna draw a line segment from C to A. Draw the line segment from C to A. Then we're gonna draw a line segment from C to B. Then we're gonna draw a line segment from B to A. And so what they're looking for is they're looking for angle B, right? Angle B. So they're looking for this particular angle right there. Like, what is this angle, right? Now, there's several things to notice here. Remember, we already know that what this is. We already know that this one is 52 degrees. We found that in our previous question. What else do we know? We also know, okay, we know that that one is 38. What else do we know? I have here angles in a triangle add up to 180 degrees. Let me see how I did it. I add 52 and 90. Why would I add 52 and 90? Somewhere here it's 90 degrees. Okay, so what I'm trying to say is that this angle here, angle C, is 90 degrees. But how do I know it's 90 degrees? What gives me that assurance that it's 90 degrees? I'm looking now. Oh, I got it. Okay, yeah. If we look carefully, that's a good point right now. If we look carefully, let me use the highlighter. If you look carefully, this this line right there is the diameter of the circle, and this right here is a semicircle. This right here is a semicircle. Let me draw it again. So again, this right here, if we go all the way around, this right here is a semicircle. And so what does that mean? Remember the theorem? The theorem says that the angle in a semicircle is 90 degrees. So that means that this angle right here, is 90 degrees. The angle in a semicircle is 90 degrees. So again, let me erase that. That means that this angle, let me use a pen instead of a highlighter. That means that this angle right here is 90 degrees, all right? This is 90 degrees. Because again, the angle formed in a semicircle is 90 degrees. So if that's 90, right? That's 90, let me erase all this. If this part is 90, right? If this one is 90, this one, that means that this part right here must also be 90. That means that this part right here must also be 90. So this part must also be 90 degrees. And the reason why this part must also be 90 because they are on the same line and they are at a common point. And remember we said about that angles, or I should say remember from geometry, that angles on the same line at a common point add up to 180 degrees. So if this is 90, that must be 90 because 90 and 90 is 180. So we know that this one, C, is 90 degrees. Why? Because this is 90. And so therefore this must be 90 because they must add up to 180 degrees. Okay, now back to trying to find what B is. So if we already know that this one is 90, that one is 52, but we're missing this one, it's a triangle. So angles in a triangle must add up to 180. So we have to add 90 and 52. And then when we add 90 and 52, we're going to subtract that from 180 to get our answer. Now what is 90 plus 52? 90 plus 52. Well, 90 plus 52 is going to be 142. That's why we have it. 90 plus 52 is going to be 142. And so we subtract 180 minus 142, and that gives us 38. 180 minus 142, that gives us 38. And so that means that this angle right here, this angle is going to be equal to 38 degrees. The reason why it's 38 is because if you were to add 90 plus 38 plus 52, they're going to equal to 90 degrees. They're going to equal to 180 degrees. Again, 90 plus 52 plus 38 is going to be equal to 180 degrees. Let's go move on to the next question. It says in the diagram O, which stands for origin, is the center of the circle, ABC, and angle ACB equals to 36. So in the diagram, O is the center of the circle ABC, and angle ACB equals to 36 degrees. The line DC is tangent to the circle at C. So we want to calculate the value of angle ABC, angle ABC. Well, the first thing we want to do here is we want to underline what B is, right? So B is the one in the middle, so we're going to be looking at this one. So B is the one in the middle. And then what we're going to do is we're going to look at angle A. Angle A is going to be this one. Then we're going to look at angle C. So C is going to be this one. Then we're gonna form a line segment. So the line segment is gonna go from B to C. It's gonna go from B to A. And it's gonna go from A to C again. So B to A, A to C. And so the one that we're looking for in particular is going to be angle B. And so we're really looking for this particular angle right there, angle B. Now, what theorem can we use to answer this question? Well, let's use the angles in a semicircle theorem. And the theorem says that the angle in a semicircle is 90 degrees. And so if we have a semicircle, right, if we have a semicircle or half a circle, the angle that's formed right here is definitely going to be 90 degrees because the angle in a semicircle is 90 degrees. And so if we look at our particular diagram, we do have a semicircle. So this right here is the diameter because O is the origin. We can clearly see that O is the origin. And if we do not know that O is the origin, then we cannot say that this is the diameter. But since O is the origin, they tell us specifically that O is the origin. We can finish this question. So right here, O is the origin. So that means that this line I'm drawing is called the diameter. And if we look here, all of this is what we call the semicircle, right? The semicircle. So all of this is called a semicircle. So that means that the angle that is in the semicircle, right here, this angle is going to be equal to 90 degrees, right? This angle right here is 90 degrees. And so this angle is 90 degrees, 90 degrees. And so that means that this right here is 90 degrees. Why? Because of the fact that the angle in a semicircle is 90 degrees. Okay, let's move on to the next question. Erase all ink. Okay, so the next question is the following. We want to figure out the size of angle BAC. So A is the one that's in the middle, so let's do that. It's going to be a point A, all right? And then we have point B. And then point C. And then we're going to draw a line segment from B to C. Draw a line segment from B to C. And then we're going to draw a line segment from B to A. And then we're going to draw a line segment from A to C, from A to C. From A to C. Okay, so now we have this shape. What we need is the one that's in the middle, which is going to be angle A. We need to figure out, okay, what is this angle right now? What is this angle? What is the size of this angle? All right. Now, in order to do this, we already know that this one is 90, right? We already know that that's 90 degrees. And we're dealing with a triangle. So that means that the angles in a triangle must add up to 180 degrees. So 36 plus 90 plus this one must add up to 180 degrees. And so let's add 90 and 36. And what is 90 plus 36? 90 plus 36 is going to be equal to 126. And then 180 minus 126 is going to be equal to 54. And so the angle, and so the reason why that's the case is because angles in a triangle add up to 180 degrees. And so that means that angle BAC, which is this one, is going to be equal to 54 degrees. So again, angle BAC, BAC is going to be equal to 54 degrees. 54 degrees. Right, the third one is calculate the value of BCD. Calculate the value of BCD. All right, so C is the one that's in the middle. All right, so let's remove that, erase all ink. So again, C is the one that's in the middle. So we're gonna outline it for C, and then we have B is right here, and then D is right here. So angle BCD. So we're gonna move from B to C, and then we're gonna move from C to D. C to D. All right, and okay, so we're looking at this particular angle because the one that's in the middle is C. And so that's the angle that we're looking at. It's important to note that this angle here, like we saw before, it was 90, right? And then also important to note that this angle we have is, we saw before, was 54 degrees. And that's because we're about to use the alternate segment theorem. And alternate segment theorem says the following. It says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so if we look carefully at this, what we'll see is we can see that we have the tangent, which is DC. We have the chord, which is BC. And the angle formed between the chord and the tangent is the one I have an asterisk. And the angle that is subtended by the chord, by the same chord, is going to be the angle that measures 54 degrees. And so that means that C is going to be equal to what? 54. And the reason why C is equal to 54 is because of the alternate segment theorem. All right. So that means that again, that means that this angle right here is going to be 54 degrees. And the reason why it's 54 is because this is 54. Okay, let's move on to the next question. It says AB is a diameter of the circle ABC with center O. AD is a tangent to the circle at A, and ABC goes to 40 degrees. Calculate angle BAC. All right, so the one that's in the middle is the one that is of is the one that is to be taken, is the one that is of utmost significance. And so angle A is the one that's in the middle, so let's consider that. Let's underline that first. And so it's gonna be A, and then B is here, and then C is here. All right. So C is right here. C is right here. So B, A, C. And so what we're gonna do is let's combine the segments. So this one is gonna go from, we're gonna go from B to A. All right, and then we're gonna go from B to C. And then we're gonna go from A to C. All right. Okay, so we're trying to figure what is the value of angle A. What is the value of angle A? So angle A would definitely be this one. That is angle A. That's the one that's we're looking at, angle A. Okay, so how are we going to figure what angle A is? What theorem can we use? Oh, okay, this theorem. So if we look carefully, there's a theorem that says that the angle between the tangent and the radius is 90 degrees. And so if we look carefully, right, let's draw the lines. This line right here, the one that's in purple, that is definitely the radius. Let's call that capital R. And then this line here, that's, I'm gonna denote it using green. This line right there, that's in green, is what we call the tangent line. That's the tangent line. So the angle formed between the radius and the tangent line, according to this question, according to the theorem rather, is 90 degrees. So that means that this right here is 90. And so the 90 includes this angle, and the 90 includes also this angle, right? So both of them are included in the 90. All right, so, and in fact, both of them make up the 90. And so this angle right here and this angle right here, then when you add them together, you get 90 degrees. Now, what is this angle right here? This particular one. Let's denote that by, let's say, this color. So let's say we want to figure like, what is this angle right here? What is this angle? Right? Now, this angle is definitely equal to 40, right? It's definitely equal to 40 because if you look carefully, that is the angle formed between the what? The chord, which is AC, and the tangent, right? So the chord AC and the tangent AD. That's what this line is. And so we could use the alternate segment theorem, and the alternate segment theorem says that the angle formed between the chord and the tangent is equal to the angle subtended by the same chord. And so if we look carefully, this angle is indeed subtended by this chord. So this angle, if we look here, this angle is subtended by the chord. So angle 40 is subtended by the chord AC, all right? So that means that if this is 40 degrees, this one must also be 40 degrees as well, all right? And so let's see, let me erase that. So again, 40 degrees is subtended by the chord AC because the legs of this angle and the angle that measures 40 degrees, the legs of it rests on the chord AC, right? The chord AC is the base of the triangle that's formed using the legs of the angle that measures 40 degrees. And so if this is 40 degrees, that means that this one right here, right? That means that this one right here, let me let me pinpoint it. If that is 40 degrees, that means that this one, let me use a different color. That means that this one right there is also 40 degrees, right? Now, that's good because that if we know that this part is 40, and we know that the whole thing is going to be equal to 90 degrees, and if we know that this part is 40, what is this part, right? This part is going to be 90 minus 40, and so that's how we get it, 90 minus 40, which is going to be equal to 50. So this part is 40, and the next part, which is this part, is going to be 50, right? So altogether, if we were to erase, let me erase everything so you can see it clearly. So erase all ink. So again, this part right here is 40 because of the alternate segment theorem. And this part right here is 50 because when you combine them in totality, they should add up to 90 degrees when you add them. 50 plus 40 should give you 90. All right. All right. So that's that. And now the next question says, calculate. Here is our link. The next question says, calculate CAD. CAD. Calculate CAD. Now, so A is going to be, let me use a red. A is going to be equal to this point right there. That's the point A. What we need C. C is going to be equal to this point right there. That's C. And then CAD. And then D is going to be equal to this point right there. This is the point D. So what we need the angle that's, well, let's join the line segment. So line segment C and A is going to be this one. Line segment A and D is going to be this one. And so the angle that they're asking us for is definitely this angle. But we found out what this angle was in the first part, because what we saw is that AD is the tangent. We saw that AC is the chord, all right? And so the angle formed between the tangent and the chord, right, is going to be equal to the angle which is subtended by the same chord. And we know that this angle, which measures 40 degrees, is subtended by the same chord because, if we look carefully, the legs of this angle, rests on the chord AC. Or you could say that the chord AC forms the base of the triangle that is formed by the legs, or that is formed by using the legs of the angle that measures 40 degrees. And so this angle, if this measures 40 degrees, this must also be 40 degrees. And so definitely this one is going to be 40 degrees because of the alternate segment theorem. Okay, let's move on to the next question. This one is from 1999. It says, calculate the size of the angle formed between the ground and the wire. Give your answer to the nearest degree. It says AB is a tangent to the circle CDE. The center is F, the center F at C, and calculate the value of X, right? We need to calculate the value of X. There's a very important theorem that is useful here to figure out the value of X. Notice that X is the one at the center. This is very important. X is the angle at the center. So let me use a pen. So X is the angle at the center, and 55 is the angle at the circumference. All right. And so the theorem says the following. The theorem says this is at the center is twice the angle at the circumference. So the theorem says the following. It says the angle at the center of the circle is twice the angle at the circumference. Again, the angle at the center of the circle is twice the angle at the circumference. So that means that this angle right here that is at the center is going to be 2 times the angle that's at the circumference. So if the angle at the circumference is 10, then the angle at the center is 2 times 10, which is 20. If the angle at the center, if the angle at the circumference is 50, then the angle at the circumference is 2 times 50, which is 100. And if the angle at the circumference is 30, then the angle at the center is going to be 2 times 30, which is 60. Every time the angle at circumference is twice, every time the angle at the center is twice the angle at the circumference. So that means that if we know that the angle at the circumference is 55, that means that the angle at the center is going to be 2 times 55, and 2 times 55 is definitely 110. So that means that X equals to 110. So here we have 110 for X, right? So it's going to be 110. So X is going to be equal to 110. Okay, let's move on to the next question. Here we want to figure out what is angle Y. And how do we figure out angle Y? I have here Y is equal to 55. What reason did I give? I used the alternate segment theorem. Okay. The reason why we use alternate segment theorem is because, let's look at it. We are looking at this right here as the tangent, right? This right here as the tangent. Did I change okay, yeah. Okay, good. This right here is the tangent, right? That's the tangent. And then this right here is going to be the chord, right? And so that means that this angle right here is the angle that's formed between the tangent, right, and the chord. And remember remember what the theorem says. The theorem says that the angle formed between the chord and the tangent, the same angle, is going to be equal to the angle that is it's going to be equal to the angle that is subtended by the same chord. And we know that this angle is subtended by the same chord because if we look at it, the legs of this angle, rests on the chord, and the chord is CE. The legs of this angle rest on the chord CE, which means that the chord CE acts as the base of a triangle that is formed using the legs of the angle that measures 55 degrees. And so definitely 55. If this is 55, this one must also be 55. And so that means that y is 55 degrees. So y is going to be 55 degrees, 5, 5. Okay, let's move on to the next question. So the next question says, let me erase all this. So what we need to remember is that this angle, which is x, equals to 110. And we got that from the beginning. We also need to know is that this line right here from C to the origin, right? That is actually a radius. And it's a radius because we know that this is the origin. They tell us that it is the origin. Did they tell us that? Yeah. They tell us that it's a center, right? And so that means that this part right there is the center. And then if we go from this part to that, right? And by the way, let me move this. Let me move the 110. By the way, this is supposed to be F because it said it's center F. So F is supposed to be right now. So this is the radius. This part is the radius, right? Because we move from the circumference to the center, which is F in this case. And then this part is also the radius from F to E, right? This part right there is also the radius from F to E. Okay. So both of them are the radius. And since both of them is the radius, that means that they are equal in measure. They're equal in length. So both of these are the radius. So that means that they are equal in length. That means that this side is equal to this side. What that also means is that the angles are equal. So that means that if this is Z, right, this must also be Z, right? Both of them are equal to the same angle. All right. And so what that means is that when we considering Z, X, and Z, we know that all of them are going to be equal to, when we add them up, all of them is going to be equal to 180 degrees. But we know that these two angles, Z and Z, are going to share the same angle. And so we already know that X is 110, so we're going to subtract 180 from, we're going to subtract 110 from 180. So we're going to subtract 110 from 180. Then we're going to divide that by 2. So 70 divided by 2 is going to be equal to 35. Okay. And so that means that the reason why we divided by 2 is because we're actually splitting it evenly because this side need to get 35. And then this side also need to get 35. And so that means that angles in the triangle add up to 180 because Z is 35, that's 35. And then this one is 110. And so 110 plus 35 plus 35, it's going to be equal to 180 degrees. Okay, moving right along to the next question. Oh, that brings us to the end of this video, and I'll see you in the next video.